All right, so today I'm going over some ACT topics. This topic in particular I'm going to focus on will be just volume. All volume. That's all I'm talking about today, volume. Eliza's parents are installing an above-ground swimming pool in their backyard. The pool is a right cylinder with a diameter of 18 feet and a height of 7 feet as shown in the figure below. Once her parents fill the pool, it will have a depth of 6 feet. What is the volume of water to the nearest cubic foot that will be in the pool once it is filled? And note, the volume formula is given. So I'm going to go through this problem on the board. Please pay attention to how I kind of speak through it and what I'm writing down as I go through it. The best thing to do is use your diagram and to write on top of it if need be. So based on this formula, pi r squared times h for volume, we know that we need a radius measurement. We don't have a radius measurement. It is implied, but we do have a diameter. And remember, the radius is half of the diameter. So even though the 18 feet is given for the diameter, it'll probably be your best bet to just go ahead and write down r is equal to 9 feet. So the given information that we will use is radius is equal to 9 feet. The height is equal to 6 feet. My teachers used to always tell me before you use a formula, write it down. And that's exactly what I have here. So I have the formula. Volume is equal to pi r squared times h. And remember, radius is 9 feet, height is 6 feet. So what we have here, we have 81 feet squared. I have a pi there, 81 feet squared, and that's 6 feet. And then from here, we just multiply, that's it. You do your 81 times your 6, and then you do that times pi. And then remember, we have feet to the second and feet. Unit analysis says we're going to have cubic feet. So we have our cubic feet. All we have to do is multiply pi times 81 times 6. All right, so when I multiply all three of these together, I get 486 pi cubic feet. And remember, we need this to be rounded to the nearest cubic foot, so I do need to multiply pi times 486. That's where I get 1,526.8 cubic feet. And since we're rounded to the nearest cubic foot, because of this 0.8, I can go ahead and bump that up to 1,527 or 1,527. So there's my final measurement. All right, so right here is the base of my pool. That's what the bottom of it would look like with an 18-foot diameter. Now, once I give it some height, this is your 3D cylinder or your right cylinder. This is what it would look like, kind of just like in the diagram. And look at what we have here. See where it says A cylinder is 1,526.81. That's the volume that we just found. So it is correct. I verified it using my computer. This type of problem is an ACT question, so you will have a calculator, or you are allowed to use a calculator. And you can verify the same numbers on your calculator. I have mine right here, and there it is there. So I got the same numbers. The common mistake most people would have made for this problem is using a height of 7 feet. And this is where reading the problem and understanding the problem is very important. If you read through it too fast or don't pay attention to what's being asked of you, you will skip over the 6 feet that I'm pointing to in the blue. Also, if you pay attention to what's underlined in green, it's telling you that the pool will have a depth, or once it's filled with water, it will have a depth of 6 feet. So we want to know how much that is when it's filled, not what the pool is itself, but how much water we use to fill the pool. What is the height in centimeters of a rectangular prism that is 80 centimeters wide, 40 centimeters long, and has a volume of 160,000 centimeters? So what makes this problem a little bit different is it's asking you for a height instead of asking you for a volume. So you're given a volume, now you have to figure out the height from the other two measurements that were given. That's one of the differences. The second difference is they never gave you the formula for the volume of a prism. So those are some things to really pay attention to. I'm gonna show you how to approach it. So here's a diagram of how this prism will look like. I have my 80 centimeters as my width. I have my 40 centimeters as my length, and my volume is 160,000 cubic centimeters. What we don't know is the height, so there's my question mark. So the volume of a rectangular prism is length times width times height. Now over here I have my 160,000 centimeters cubed. I have my 80 centimeters times my 40 centimeters, which gives me 3,200 centimeters squared. All right, so centimeters times centimeters is centimeters to the second power. Now I can divide both of these by 3,200, and then that's what's going to give me my height. And there it is. When I divide both sides by 3,200, I have 50 centimeters. So my height is 50 centimeters. All right, so here's my diagram. I have my 80 times my 40, so I have that. But now I have it here where you can actually see what it looks like as a 3D object. And as you can see here, as I drag this around, so this has a height of 5. And if you notice, at a height of 5, that's 16,000. So be real careful. 5, that's 16,000. But as I drag through, notice as that the volume keeps changing. And then there it is at 50. This has a volume of 160,000 cubic centimeters. So based on the height, the volume does change. All right. And there's the correct one right there. All right, so let's talk about one more approach. So you can multiply 80 centimeters times 40 centimeters, and that right there will give you 3,200. So we can start with the 3,200. 3,200 times 5. 3,200 times 20. 3,200 times 39. 3,200 times 40. 3,200 times 50. One of those are going to give you 160,000, and that's going to be your correct answer.